Hi, welcome back. In this video we will talk about exceptions, which is a kind of way in Python to signalize error and also to handle errors. So let's have first have a look at an example. We have here a very simple Python code. We are just initializing a string with a certain content, and then we are trying to basically to convert this string into an integer. If the string would represent a proper integer, then it could be converted, but because the string is definitely not an integer, there will be an error should happen here. If you execute it in Python, you will see that indeed you get a so-called value error, and it will basically complain that it's impossible to convert the letters A and B or interpret the letters A and B as an integer with base 10. And actually, this was already an exception which was raised. In the error message which we have here, we have information about where the error occurred. So in this case, it was the second line of my code, which was the conversion from string to integer. I have a so-called exception class, which is value error. This gives me a kind of information what kind of error I have seen. And I have an error message which should give me a little bit more details about what the reason for the exception for the error was. So basically, these exceptions are used to signalize errors, and if there is some condition happens which Python cannot handle or doesn't want to handle, then an exception is raised. The exceptions are in a so-called class hierarchy, which we will see in a minute what it means. Now, but let's have a look at a bit more complicated example first. We are looking about this code here. We have two functions, and the first function is called, and then the first function calls the second function, and in the second function we are doing something which cannot be done by Python, again converting something which is meaningless into an integer, which should raise an exception. If we actually indeed let it run, then we will see that f1 start is printed, f2 start, the strings f2 starts are printed, and then basically I have only the error message showing me the place where the error happened, and also showing me that it was a value error with the message which I just omitted here. Now let's have a bit more detailed look at what exactly happens here. So basically, first I'm calling f1, and f1 calls the routine f1. Then it prints the string f1 start, which we have here. And then basically f2 is called. At the routine f2, we enter the routine f2. Then the string f2 start is printed, and then we do something which Python cannot really do. We try to do something, so an exception is raised. And because this exception is not handled here, not called here, we will see later how we can do that, but at the moment we don't do anything with that exception. The execution of the subroutine f2 is stopped here, and we are returning to the place from which f2 was called. At this point, we are also not doing anything with the exception, so the exception is still there, we didn't handle it. So as the next thing, we would from here return to the point where f1 was called, which is that line here. Again, we are not handling the exception also here, we are not doing anything special, so we would return to what called this line here, but this is already the main script, and therefore basically Python will just stop the code. And what we see here in the error message of the exception, we see the entire so-called call stack trace. So basically we see the lines, the line which was causing the problem, and in the backwards way we see how we basically reached those lines. So basically this line was in the routine f2, which was called as f2 in line 3, which was called as f1 in line 11. So basically, a part of the error message itself, we also get information about how we reached this point. So what was the series of calls which led us to this point, which can be super helpful when we try to understand why the error happened. And it's important to know that it's always the most recent call which is has shown last. So first you should look always at the very last line of the error message of the stack trace, because this shows you the exact position where the exception was raised, and then you can go back to find out how you reached that point. So we have said, I have said we can handle the exceptions, and this is indeed you can do. And there are certain cases where we should do that. Let's assume here we have an example. I'm reading in a file. You know, you want already how to open a file and read it. And if this file name, fname, is coming from the user, and we are just trying to open it, it could very easily happen that the user just mistyped the file name, or the file is not there, also it is supposed to be there. And then, of course, an exception would be raised. The exception class this time would be the file not found error. So basically it would say, yes, I could not find the file. And then the exception would propagate it upwards, as we learned before, and the program stopped. However, sometimes you want to be able to handle this error or write something to the user before you stop the code. So basically, if there's a fair chance that an exception will happen, very typical for file opening, then maybe we should guard it and try to catch, so-called catch this exception. And catching an exception can be done, and we will have a detailed look in the next slide, but already here I want to demonstrate it with a try except construct. So basically we are putting the statement which might raise an exception into the try block. And if the exception indeed, or if the code here indeed raises an exception, here in this case the file not found error exception, then the block which is specified in the except block with the file not found error would be executed. So here we can basically make sure that we are printing a nice error message to the user instead of having something like this. This is good for debugging, but it is not something the user should necessarily see. Or we could, instead of printing just an error message, maybe we could also go for a default file, or there are many ways how we can handle it. And in order to make sure that the exception doesn't propagate up and stops the code, we can just have this try except block, where we, as I said, in the try block we write a statement which might raise the exception, and in the except block we write the code which should be executed if a certain exception was raised. Here it's a little bit more complicated example. The try except block can also have an else clause. What does it mean? This block would be the else would be executed if there was no exception. So basically here again I'm just opening the file, and then I have here an exception catching. I try to deal with the case when a file not found error was raised. But if that was not the case, that means there was no exception raised, then I can indeed read in the file, close it, and do whatever I want with that. Very important to know that there are multiple except blocks possible. We will have also an example on the next slide. And if you have multiple examples, then the first matching example is the one which is executed. And if there was an exception and none of the except blocks matches, so basically none of the exceptions for which I created an except block matches, then the exception would propagate it upwards, as we have seen before, as if the statement had been executed outside of a try block. Okay, maybe a little bit more detail on the except block. You can also store the exception, the details of the exception, in a variable. So every exception is actually in a variable instance or an instance variable of a class. And you can store the exception in a variable which you can specify here with the s modifier, so xs statement, so except. Then you are specifying the exception class, then the s statement, and then a very arbitrary variable name which I call here exc, like exception. And then basically you can, for example, print the exception as a string. And if you print the exception, the stored exception as a string, then you get exactly the same error message which we usually see if you do not handle the exception. So basically you can gain exactly the same string. And the exception object which you stored has also a so-called args field, arguments field, and the exception which contains the exception arguments, in this case the number 2. Why? Because it was the error number 2, so the integer 2, so you can inspect and investigate which error number actually occurred, and again one more, the reason of the exception as a string. So it's possible to investigate the details of the exception. Which arguments an exception has and what they are in those arguments. This differs from exception for exception. So basically you should look up the documentation of the exception you are catching and then look it up which kind of arguments it provides. So I said already, we can have multiple except clauses. For example, if you open a file, there are multiple reasons why this file opening could fail. One possibility is that the file was not found, then it would raise a file not found exception. But maybe the file is there, but it cannot read by you because you don't. There are the wrong permissions set, and then you would get a permission error. And it's very important to know that if you have multiple exceptions, the first matching will be executed. In this case, it's not a problem because file not found error and permission error are independent from each other. But you might can have also exceptions which are not independent from each other, and then it's important to know that it's always the first matching block which is executed. So how can it be that you have exceptions which are not independent from each other? This is because the exceptions are organized in a so-called class hierarchy. We didn't talk about object-oriented programming yet and about classes, so I will just make the explanation here very simple. Think about that, that if you open a file, there can be many different errors which can occur. One possibility, as we have seen, that the file is not found. Another possibility is the file is found, but the permissions are not correct, and therefore the user who runs your code cannot open this file. Or the file is there, the permissions are okay, but for whatever reasons, for example, this file is somewhere on a network drive, there is a timeout error, so it takes too long. And each of these could stop the program and raise the according exception. Now I could write, of course, a try and except block with an except block for this exception, with an except block for this exception, and an except block for this exception. But in many cases, I don't want to distinguish between those cases because for me it's only important the file could not be open. And there is a generic exception which represents all of those, which is called OS error. So basically, if I'm investigating OS error in an except block, it will match if the file was not found, it will match if the permission was not correct, and it will also match if there was a timeout. If we talk about object-oriented language, if you know already a little bit object-oriented programming and class hierarchies, then basically all these three exceptions are children classes or derived classes of the parent class of the or a base class OS error. And if Python sees somewhere a base class, then basically it represents all the derived exceptions. What does it mean? In our example, when I open the file, I could just say, okay, except OS error. And if any kind of error happened which has to do with the operating system, because so that the operating system could not open the file, then I will handle it somehow, and the details, whether it was a file not found error, a permission error, or a timeout error, are here irrelevant. So let's assume we have an exception and we code it, we are handling it, and at the end we realize that we have to exit the program anyway. Then you can do that with the so-called sys.exit command, so the exit command from the sys module. And then this exit command takes also an argument, and you can pass it a number, and depending on this number, the operating system can tell whether the program execution was successful or not. So let's have an example to that. I'm importing here the sys module, and I have a try clause again for just opening the file, input.dat, and I try to read it, right? And then if it didn't, if I didn't manage because there was some OS error, so the details which specific error is not important, any kind of file-related operating system error, then I'm just printing some message for the user, and then I am just exiting the code, because if the input file could not be found, then probably I cannot do anything further in this program. The sys.exit function, which I called, this function will never return. It will stop the code execution and abort basically the Python interpreter and the execution of our code. Here I'm passing here a number 1, so and something which is the non-zero number. The convention is we are passing a 0 number to the operating system if the execution was successful, and a non-zero number, typically a positive number, if the execution was not successful. It's very important that the sys.exit you should only call in your main program at the very, very highest level. So do not try to call it from functions inside. it's possible in Python, but it's considered to be a very bad practice. So always if a function has a problem and encounter the situation where it cannot handle the arguments, or it cannot handle something, then it should raise an exception. The exception should propagate up in your code at the very, very, very highest level. You should call assist.exit, right? But only at the very highest level. Now, how can we raise an exception ourselves? This is also quite easy to do. So let's assume we have a linear solver, a solver of linear system of equations, and we are just investigating a certain condition. And if this condition is true, then it turns out it's the condition that our matrix is singular, and then we cannot solve the linear system of equations. So we want to return from the function, from the solver function. And what we can do is we can just call the raise statement, which raises an exception, and we have to create an exception. Here I'm creating a value exception, so basically an exception from the class value exception, and I am passing it as a first argument. And it's very typical. Basically all exception has a first argument, a message, which gives some details. So in this case the message is singular matrix. And if I'm raising this exception, that the code execution, program execution will be stopped here, and the exception the code execution will leave the function which I am in, and the exception would start to propagate up, as we have seen before, until a point where it's handled, or if it's not handled, then at the end it would stop the code. Sometimes the exceptions, the built-in exception of Pythons, are not good enough for your purposes. You can also define your own exception. This is again a little bit has to do with object-oriented programming. But basically you can make an exception class, your own exception class. Here I call it linear error. The convention is that if you make an exception, then you call it error if it's a user exception. So I'm calling it linear error, and I'm deriving it from the generic exception class called exception. So that would be here the way of do that. So deriving from the exception class. And then here I just have a docstring, and you can also add, if you want, some additional parameters which this exception can record and transport, so that the details of the exception of the problem can be investigated when the exception propagates up, and somewhere it's called with an except clause. Now the last thing we have to have a look at that, how we test things in PyTest. So how can we know, let's assume our linear algebra routine indeed raises an exception, how we can test in PyTest whether that's the case. Usually exceptions would travel up and stop our testing routine, unless we are using a context manager pytest.raises. Right, context manager we have learned about when we're opening file, for example. They are introduced with the with statement, and then here we call the pytest.raises function, and in order to create a context manager, and we are passing the pytest.raises function the name of the exception, or the class of the exception we want to look at. And within this context block here, indented within this block, we are calling our, for example, Gaussian eliminate routine. And then if this Gaussian eliminate routine raises a value error exception, then basically that would be called here, and then the test would be considered as successful. If the call to this function does not raise the exception, or it does not raise any exception, or it doesn't raise the value error exception, then the test would be considered as failed. Right? So basically it would look for a specific exception. We can also have a look at the message in the exception. So basically if you call the pytest raises function with the additional optional argument match, let's say we are saying match singular matrix, then basically this will be only considered successful, this construct, if the exception was a value error exception and the message of the exception was exactly the singular matrix, the string singular matrix. You can also pass regular patterns here if you want. So this is the way how we test it in PyTest, and because now we can also test it in PyTest, we can write now programs which are communicating errors via exception. It's very important to note that here, when you are watching your expression, you should not take a too generic exception, right? So basically, if you know that your Gaussian eliminate is going to raise a value error, then please make sure that you are putting value error here. Of course, you could also put a more generic exception, but that wouldn't be very meaningful, because then you may catch also exceptions which will raise for some other reasons. So here we also always very specific, and they take the exception which you really know that your routine can indeed raise.